So we have been seeing about the different components of the Hadoop ecosystem. In the previous session, we did try to see how exactly MapReduce works, the different phases of MapReduce, that is mapper phase, shuffle and sort phase, in reducer phase. We did see an example, fruit example, is after how exactly we try to mention those value of those key. So you name that fruit as the key, and then the value of each keys and put them together as key value pairs. The mapper, shuffle and sort them, reduce in family. You try to have the output of it. So map reduce, you can remember it as divide and conquer, aggregate and summarize for reduce. So divide and conquer for map phase, aggregate and summarize for the each phase. So with that said, we understood the example and also saw the MCQs for the particular topic and also one to descriptive questions. So now we will get into the topic, another component of Hadoop ecosystem, which is Hadoop distributed file system, HDFS. So we'll see one by one. So beginning with what exactly is the Hadoop file system, the Hadoop distributed file system. So it is a foundational component of the Hadoop ecosystem. The foundational component of the Hadoop ecosystem is this Hadoop distributed file system. It's the mechanism by which a large amount of data can be distributed over a cluster of computers. The data is written once but read many times for so large amount of data can be distributed over a cluster of computers. Data is written once and it is being read many times for analytical reasons. So it provides the foundation for other tools such as HDFS. So HDFS is the default storage file system in Hadoop, which is distributed, considerably simple in design, and extremely scalable, flexible, and with high fault tolerance accessible. So default storage system, so this has to be noted, which is distributed. So Hadoop distributed file system architecture is a master-slave pattern due to which the slave and being managed in users. So on the whole, what exactly is this Hadoop distributed file system? It is a file system, but unlike the one on your laptop, it's distributed across potentially thousands of machines. This allows it to scale horizontally. If you need more storage, you just add more servers. It's built from the ground up to be fault tolerant, assuming that hardware will fail. Best of all, it achieves this using standard off-the-shelf hardware, which makes it very cost effective. So off-the-shelf hardware, which makes it cost effective. So the architecture of HDFS is surprisingly simple. It's master-slave setup. So there is one name node which acts as the master or the brain of the system. Then there are many data nodes which are the slaves or the muscle. A client application like a MapReduce job, will talk to the name node to figure out where the data is and then talk directly to the data nodes to read or write that data. So we have name node, which acts as the master, data node, slaves are the master. So client application is something like a MapReduce job. We talk to the name node way to figure out where the data is and then talk to the data node to write it, to read and write that particular data. So HDFS can even run on commodity hardware and the architecture accepts that some nodes can be down and still data has to be recovered and processed. HDFS has self-healing processes and speculative execution, which make the system fault tolerant and is flexible to add or remove nodes and increases the scalability with reliability. So HDFS is designed to be best suited for MapReduce programming. One key assumption in HDFS is moving computation is cheaper than moving data. So we repeat that. So it's designed to best suited for MapReduce programming. The key assumption in HDFS is moving computation is cheaper than moving data. Okay. So HDFS doesn't store files as single entities. It chops them down into large blocks, usually 128 or 256 megabytes. This is much larger than traditional file systems. To ensure fault tolerance, each block is copied and stored on multiple data nodes. That is the muscle. The default is 3 copies. This means if one or even 2 data nodes holding a copy of a block fail, the data is still saved. So this is one of the vital features of HDFS. So other features are like scalability. So HDFS is scalable to petabytes or even more. Hadoop distributed file system is flexible enough to add or remove nodes which can achieve scalability. So you're able to extend it to the extent that you're looking for. So Hadoop distributed file system provides you that opportunity. Other features are like reliability and fault tolerance. So Hadoop distributed file system replicates the data to a configurable parameter, which gives flexibility of getting high reliability and increases the fault tolerance of a system. As data will be stored in multiple nodes, and even if a few nodes are down, data can be accessed from other available nodes. Other feature is data coherency. HDFS has the one, that is write once, read many. So Hadoop distributed file system has the one model, write once, read many, which simplifies the data coherency and gives high throughput. So we still have some more features. So before that, to use HDFS, that is Hadoop distributed file system effectively, we need to understand its core philosophy. It's built for a warm access pattern, that is write once, read many access pattern. It's also based on the principle that it's far more efficient to move a small processing job to the data rather than moving terabytes of data across the network to the job. Let me repeat that. It's based on the principle that it's far more efficient to move a small processing job of data rather than moving terabytes of data across the network to the job. Finally, it prioritizes throughput, the rate at which it can deliver large amount of data. Over latency, which is the speed of a single small request. So, hardware failure recovery. Hadoop distributed file system assumes some nodes in the cluster can fail and has a good failure recovery processes which allows Hadoop distributed file system to run in commodity hardwares. HDFS has failover processes which can recover the data and handle failure recovery. So other feature is portability. HDFS is portable on different hardwares and softwares. So you can try and utilize it whatever that you're looking for. Another feature is computation closer to data. So Hadoop distributed file system moves the computation process towards the data instead of pulling data out for computation, which is much faster as data is distributed and ideal for the map reduced process. So these are the features of Hadoop distributed file system. So we've got an idea about what is Hadoop distributed file system, why exactly it's being followed in the ecosystem, and the different features like fault tolerance, portability, hardware failure, Hadoop distributed file system. With that said, let us see the limitations of the Hadoop distributed file systems. Low latency data access, so it's not suitable for applications that need real-time sub-second responses. That is, instance, we can refer to transactional databases. The small files problem. Storing millions of small files is very inefficient. The name nodes in memory gets overwhelmed by all the metadata with all those small files being stored. Then another limitation is frequent file modifications. The write once model makes in place edit to files impossible or extremely complex. So latency, small files issues, and frequent file modifications are some of the limitations of the Hadoop distributed file system. So it is extremely vital to understand no technology is perfect for every use case, and Hadoop distributed file system is no exception. It's a bad choice for applications needing low latency access, like a website's user database. It also struggles with the small files problem. Every file's metadata must be in the name nodes, RAM. Millions of tiny files can exhaust its memory. So your application needs to be constantly modifying its existing files. With all these limitations, there is a possibility you can say Hadoop distributed file system may not be the right for you. So on the whole, HDFS is the powerful storage foundation of the Hadoop world. It allows us to reliably store massive data sets across clusters of inexpensive machines. Its master slave architecture, use of data replication, and design for high throughput batch processing make it the go-to solution for big data storage challenges. So the master slave architecture, data replication, high throughput batch processing make it the go-to solution for big data storage challenges. So let us try to solve this MCQs in relation to the Hadoop data, Hadoop distributed file systems. So the first question is about the purpose of Hadoop distributed file system. There are options for that. The second one is what key principle does Hadoop distributed file system follow regarding data processing? So you can try to choose the options of listed. So these topics were discussed now. We will take some time. Let's take again 3 minutes of duration so that we select which one is the right answer. Then your time starts. So it's time for the first question. So we'll move on to the next one. Still have another 1 minute. The second question. It's almost time. Okay. So let us discuss the first question. What is the purpose of Hadoop distributed file system? The first option is to process data in real time. The second is to store and manage large datasets across multiple nodes. Third is to provide security for data stored in Hadoop. The fourth is to analyze data using machine learning algorithms. So the right answer for the purpose of Hadoop distributed file system is to store and manage large data sets across multiple nodes. So it's not about processing data in real time, or security, analyzing data using machine learning algorithms. It's about storing and managing large data sets across nodes. Now, let's see the next question. What key principle does Hadoop distributed file system follow regarding data processing? So the options are moving data is cheaper than moving computation. Moving computation is cheaper than moving data. Data should always be processed on a single node. Computation should never be distributed. So out of these four options, the key principle Hadoop distributed file system follows regarding data processing is moving computation is cheaper than moving data. That is the right answer. It's not about moving data, it's going to be expensive because it's going to be huge amount of data. Data should always be processed on single node is not a principle and computation should never be distributed is not the principle. Okay, so the correct answer is moving computation being cheaper than moving data. I hope most of you got this question right because we are clearly discussed about the purpose of HDFS is the Hadoop distributed file systems to store and manage large data set across multiple nodes. And the principle is about moving computation being cheaper than moving data, which is humongous amounts. It's a result. So next is the descriptive question. So for this topic, we have one descriptive question, which is analyze how does Hadoop distributed file system ensure fault tolerance and data replication in the event of node failures. Is Hadoop distributed file system, how can it help with the fault tolerance and data replication when there is node failures? So what you can do is you can just take a notebook and a pen and start listing out what are all the key points that you list out for this. We will discuss that in a short while. So your time starts moving. just take another minute to list out the key points to this question. Okay. Now let us discuss this question on how does Hadoop distributed file system ensure fault tolerance and data replication in the event of node failures. So it's data replication. We have replication factor and placement policy. Another aspect is fault tolerance, in which we are referring to the name node and data node, which acts as the master slave, brain and muscle. And we can talk about the heartbeat mechanism in log reports, rack awareness, data transfer protocol, and checksums. So for this particular question on how does Hadoop distributed file system ensures fault tolerance and data application, we are even to use. You have to detail on replication factor and placement policy with respect to the data application in name node, data node, in regards to the fault tolerance, and also briefly provide information on these aspects, that is heartbeat mechanism, log reports, lack of awareness, data transfer protocol, checksums. So we hope people have listed out some of these topics for this particular question on Hadoop distributed file system, part of application with respect to this. So with that, we come to the end of this particular session where we did discuss about Hadoop distributed file system purpose and how exactly it works, the features of Hadoop distributed file system. We also try to test your understanding on this topic with some MCQ descriptive questions. Now, if you need more information, you can try to refer to this book titled Big Data Analytics, published by Wiley publication back in 2020, which should have additional information on some more examples to give you some broad understanding. What is this Hadoop distributed file system? How exactly complements the Hadoop ecosystem, the foundation for storing the data, making progress towards big data analytics. So thank you for your patience in listening to this video and understanding how this Hadoop distributed file system really works in the Hadoop ecosystem. Now, the upcoming topics we will be discussing on the other components of the Hadoop ecosystem, that is, other than Hadoop distributed file system, we will talk about high HDFS to actually spark this world. Thank you.